So, hello everyone, I'm Srisha. I'm the team leader of Arabian Nights. So, today I'll be demonstrating you our prototype. So, this is our dashboard. Here we get some real time data and we do some risk analysis and show how safe it is to go outside and stuff. So, our problem statement was to forecast O3, ozone, and nitrogen dioxide levels, ground levels on of Delhi, of 7 sites. So this problem statement was given by the Indian Space Organization or ISRO. So we picked this problem statement because me and my friends, teammates were really enthusiastic about quantitative finance, and this aligned really close with our expertise. So we have picked this problem statement, and this was our dashboard. Now I'm going to the main page where the forecasting and the model lies. So here, if you come here, you have a right sidebar where you can adjust the parameters and the select your models. So here we have found out the light GBM model, fine-tuned as the best one. So I'll select this as of now. Choose this because of this reason. And here you can adjust the model parameters. But this model is already pre-trained and it will load according to the hyperparameters given. And this is the scaling for pre-processing of the data. And this also shows the variance of the data, how much the data can vary uh, in a given time period. This is exceptionally useful for quantifying risk, uncertainties, and certain occasions. So I'll add check that option as well. And here you can check the time range of the data. So I'm going some random range to 2020. So, and this here you can select the sites where you want the data from. So before I hit the fetch forecast, I'll explain what's happening behind the screens. So here the raw data was given by ISRO, and this is the features which exist in the raw data, and this was taken into our advanced feature engineering pipeline, where we add 40 more features, exogenous features, which are inferred from the reanalysis data, which is reconstructed forecasting data, and temperature, forecasted wind speeds from different directions, and other meteorological data and satellite data. And we have extrapolated lag features, log features, and many other transformations on the data so that we achieve a high quality feature set. And then we split the data. We had around 25,000 data points and we split it into this config. And we had two different approaches, both doing two separate jobs. One is direct forecasting, which gives you the uh, direct values of the pollutants in the atmosphere on that day. And we have used gradient boosting ensemble models like GBM and random forest and boosting methods. And we have achieved the best RMSE so far, 1.220. And we have also used LSTM transformers and NBEAT models, which have also given us a fairly good RMSE, but we will actually get to know on different sets of data and different conditions. And for the risk and variance, where you want to find the risk on a particular day or the variance, how much it can vary in a particular time period, we have used quantile gradient boosting, where the error function is essentially changed from RMSE to some quantile functions. And we have used the same here in Bayesian neural nets as well. And these are some of the models which we have found out to be the best for this data. We have experimented with 20 plus models, and we have trained all the models, and the hyperparameter tuning took us more than 40 plus hours. So we have trained the model, and these models are present in the UI as well, and the inference is on our UI. So now we come back to the prototype, and I'll hit the fetch forecast. So here, as you can see here, these are the forecasted data. You might be wondering, why is it stopping till 2022 as I'm mentioning forecasting? So the data provided by this row is not of the nature which you are anticipating it to be in, because what they have done is taken the data from 2019 to 2024 and picked out some sections of the data and put it in the unseen data, which they will measure the error rates during the SIH hackathon, which is going to be happening soon. So our data will be compared with the actual data which they have and which none of the participants have, and they're going to check on it. So our main task was to get the features particular feature which we have engineered and forecast the actual values on a given time period. The granularity of the data is each hour, so I can't demonstrate all the values in a single graph. I've used weekly sampling, so it doesn't really matter for the nature of data we have. We get an zoomed in version as well. And here you can see the variance, how much it has varied. During 2020, it varied a lot because of COVID and other reasons. The sudden increase in as the lockdown opened up, there was a sudden increase in pollutants. You can see it clearly here. And then here are the parameters of our model. R squared is around around 1. RMSE is 1.2 as I stated before. And the correlation is 0.999, which is exceptional, and it is statistically 100% correlation. So whenever a model suggests it's going up, it's gonna go up based on the analysis and other features. And so we have trained two different models everywhere for NO2 and O3. So you can download the model directly from here, and also you can see what each metric means here. And here are the actual forecasted details. Here you can download the same as well. So this has been our prototype. And if you want to see the real models which we have trained, it's here. And this is the nature of data. This is the data. The blue markers are the ones which were given in the training set. These for these data, we have the target, so we can train the models. For the red ones, it was taken from in between of the data which we already have. So it has been exceptionally tough for us to engineer this accordingly. So these are the forecasted models, and we have, according to our testing, we have found it out to these XGBoost and gradient boosting models work exceptionally well on these type of data. And we were surprised by the results as it was really good. So to ensure it is not overfitting or there is no data leakage in our pipeline, so we consulted some experts who reviewed our models, and they have given us a green flag to go ahead with the models as they found no overfitting or any other problems. So these are the features which we modified, and this is the forecast for the ozone as well. So the data looks absolutely normal and as it should be, and we have achieved an exceptional result so far. So we are trying to use other more models. If we get qualified, we'll try to implement more and more models with even better facilities. We have so far used RTX 3090s and A100 and P100 GPUs so far, and we have trained it for 40 plus hours. So this has been our prototype, and we will provide all the collab notebooks and everything to in the PPT, and we'll provide our case study which we did on the impact of the pollution in Delhi as well. So thank you. That's all.